Hello, welcome to this session in Applied Physics. We have already studied forces and friction, heat and mechanics. Today we will be looking at light. What is light? What are the various theories of light? How is color produced? These are some of the things we will be looking into today. Let's begin with light. What is light? Is it material? Is it an energy? How does it travel? How fast does it travel? These and many other questions on light have been debated since ancient times. One of the earliest theories was that light was a fluid emanating from the object, and when this fluid entered the eye, it produces the sensation of sight. Another theory was that the fluid came from the eye, and when it met an object, it became visible. Then perhaps to integrate both the theories, people came up with this theory that there was two kinds of fluids, one from the object and one from the eye, and when the two fluids met, the vision resulted. The term light may now be described as a form of energy that causes the sensation of light. Today we know that light, it is more appropriate to say that light is an electromagnetic wave where the electric and magnetic fields propagate through the medium. Velocity of light. The velocity at which light travels has been measured by various methods, but one of the most accurate measurement was done by Michelson, who set up his apparatus at the observatory on Mount Wilson in California. A beam of light hit one side of a mirror and was reflected to a stationary mirror 35 kilometers away on a mountain top. This beam was bounced back to a rotating mirror. As long as the rotating mirror has spun exactly 1/8 of a turn, the next side is the correct position to reflect the light to an observer looking through a telescope. From the distance the light travelled and the rate of rotation of the mirror, Michelson calculated the velocity of light from the formula velocity is equal to distance divided by time. This velocity is approximately 186,000 miles per second or 3 into 10 to the power of 8 meters per second. It is an interesting point that according to Einstein's theory of relativity, nothing can break the speed of light. The subject matter of optics, which basically deals with light, is divided into three parts. These are geometrical optics or ray optics, physical optics or wave optics, and quantum optics. In geometrical optics, we assume that light has a rectilinear propagation, that is, light travels in straight lines, and the propagation of light can be described by light rays. Here we study about the phenomena of reflection and refraction of the light, and thus about mirrors, lenses, prisms and aberrations, defects of images. Geometrical optics is based on Newton's corpuscular theory. According to this theory, light consists of corpuscles or particles, which were supposed to be having no mass but capable of travelling at a very high speed. When a source of light is switched on, corpuscles or the particles shot out from the source. When these fall on the retina, they cause the sensation of sight. Since the corpuscles have a high speed, they are supposed to travel in straight lines. Geometrical optics is successful to some extent in explaining and understanding the principles of reflection and refraction of light and working of optical instruments. However, it fails to explain some other phenomena such as interference, diffraction, and polarization of light exhibited by light. Geometrical optics is the limiting case of wave optics. These suggest that light behaved more like a wave rather than a particle. Physical optics deals with the physical nature of light and the propagation of light as a wave motion. This idea was first proposed by Christian Huygens, who suggested that light is a form of energy that travels like a wave through the medium of ether. Quantum optics deals with the interaction of light with matter. The phenomena of photoelectric effect, Compton effect, etc. are the examples of topics studied under quantum optics. We shall now look at wave theory of light. After the failure of corpuscular theory, that is a theory of particles, a group of scientists, Huygens, Young and Fresnel, proposed a new theory in the name of the wave theory of light. According to this theory, light energy is propagated in the form of a wave disturbance. Wave motion is a mode of propagation of energy through a medium from one point to other by the vibration of the particles in the medium. To explain the propagation of light from stars and the sun to far-off regions, the supporters of the wave theory were forced to assume the existence of a medium called ether. Ether was supposed to be massless and invisible. Using the wave theory, not only reflection and refraction but also various other phenomena of light like interference, diffraction and polarization were successfully explained. Huygens' wave theory predicted that light travels faster in rarer media than denser media, whereas Newton's corpuscular theory predicted the opposite. This conflict between the two theories went on for a long time until Foucault provided the necessary experimental confirmation, which was in favor of Huygens' wave theory. The most serious drawback, however, of the wave theory was its dependence on an existence of a medium called ether. Experiments were carried out to prove the existence of this ether, but without any success. Hence, the idea of ether was totally abandoned. Max Planck proposed the photon theory. According to Planck, emission or absorption of light occurs in the form of concentrated bundles of energy called photon or quanta. Thus, once again, the corpuscular idea of light came into existence. This could explain photoelectric effect seen with some materials where light falling on a material is converted into electricity. The quantum theory in general sees energy as made of discrete particles propagating as waves. Light, it turns out, can act both as a wave and a particle. The quantum theory also lends this dual nature to matter so that even particle constituents like electrons and protons behave both like particles and waves. In fact, it goes on to describe weird characteristics in the world of atoms, where a particle can be at any point in space at any time. It is only the act of measurement that produces a particle at one particular point. What is color? You have studied that a substance looks the color it is because of the light it reflects. A flower may look red because it reflects red color. Object may look blue because it reflects back the blue color. But what exactly is this color? How is this color produced? Color is a characteristic of light where the frequency of light produces a certain color. The word is used in several senses, but in the sense of physics, it is the frequency which is most associated with the color. Let us look at how the scientists came upon these aspects. The word is used in several senses and color may be studied by various points of view. To the average person, color means the various sensations which are registered in the mind through the sense of sight. Light is the source of color, as was first demonstrated by Isaac Newton in 1666 at the age of 23. How did Newton discover this? Newton passed a ray of sunlight through a glass prism to produce a rainbow effect. He then passed these rays through a second prism to reproduce a single ray of light. So, Newton concluded that color is in the light and that white light is a mixture of all the colors in the visible spectrum. When light strikes a surface, the surface will absorb some of the colors and reflect others. It is the reflected colors we see. So, when you say an object absorbs color, it means it absorbs the frequency of the color, and the frequency which is reflected is the color that is seen by the eye. How can we produce the various colors? In 1801, Thomas Young suggested that the human eye contains 3 types of color sensitive receptors. One was sensitive to blue light, one to green light and one to red. Another method called the subtractive process was first developed independently by 2 Frenchmen, Charles Cros and Louis Ducot, in the 1860s. If a color is produced by absorbing certain wavelengths so that only a part of the incident light is reflected or transmitted, the color has been produced by the subtractive method. The subtractive process uses 3 filters to remove unwanted colors from white light. There are 3 layers. The yellow layer absorbs blue light, the magenta layer absorbs green light and the cyan layer absorbs red light. The subtractive process works by taking color away from white light by using yellow, cyan and magenta filters. Where 2 of the filters overlap, they pass red, green or blue light depending upon the pair of filters. Where all 3 overlap, all wavelengths are blocked. Another method, additive method process, where separate colored lights combine to form other colors. When green, red and blue light overlap, the combination is white light. Any color combination may be produced by using proper proportions of red, green and blue light. Moreover, none of these 3 colors can be produced by combining any other color. Therefore, red, green and blue are the 3 additive primary colors. The following colors may be produced by adding primary colors of light. Red and blue gives purple, red and green gives yellow, blue and green gives blue-green. So, what we have seen is, according to Newton, light consists of corpuscles or particles, which were supposed to be material particles with no mass but capable of travelling at a very high speed. Light is a form of energy which makes the objects visible to eye, and it does not require a medium for propagation. After the failure of corpuscular theory, a group of scientists, Huygens, Young and Fresnel, proposed a new theory in the name of wave theory. Any color combination may be produced by using proper proportions of red, blue and green light. I hope you enjoyed this session on light. Thank you.